वेलकम टू आवर चैनल बी ऑलवेज लर्नर। वीडियो में हम टाइम स्केलिंग प्रॉपर्टी फोरियर ट्रांसफॉर्म की कवर करेंगे। आपको वीडियो पसंद आएगा, आप लाइक करिए, शेयर करिए, चैनल को सब्सक्राइब करिए और बेल आइकन दबाना मत भूलिए। तो टाइम स्केलिंग प्रॉपर्टी, वी कैन से दैट if the Fourier transform of xt is equal to capital X j omega, then the Fourier transform of टाइम स्केल्ड सिग्नल, जब हम t को a से मल्टीप्लाई करेंगे या किसी कांस्टेंट से मल्टीप्लाई करेंगे, देन इट इज टाइम स्केल्ड सिग्नल, दैट इज इक्वल टू 1 बाय a absolute value of a, then x is a function of j omega by a। तो पहले हम इसको प्रूफ ड्राइव करेंगे एंड देन वी विल अंडरस्टैंड द that is, we can follow the two conditions here, that if a is greater than 0, then we can write that Fourier transform of xat time scale signal is equal to, by definition we can write down the integration from minus infinity to infinity xat e raised to the power minus j omega t and dt back to time. So we can have this and we can take at is equal to p, then p is equal to or we can say that t is equal to p by a, and we can also write the value of dt is equal to 1 by a dp. So after putting all these values, we can have next step, that is equal to integration from minus infinity to infinity xp at is equal to p e raised to the power minus j omega, value of t is p by a, and with respect to dp. Now dp dt is equal to 1 over a into dp. We can write it like this. So that is equal to 1 over a integration from minus infinity to infinity xp. Now this term can be written as e raised to the power minus j omega by a with respect to p, because a यहाँ पर constant है, तो we can write it like this. Now this one is written as 1 by a minus infinity to infinity, or we can directly write that this by definition is equal to x j omega by a. Fine. So similarly, we can calculate if a is less than 0, and we can have that if this is less than 0, then Fourier transform of x at is equal to integration from minus infinity to infinity. By definition we can write x at is equal to e raised to the power minus j omega t dt, and we can have, after putting all the values, we can have that is equal to minus 1 by a x j omega by a. Now because the term, hence we can write the Fourier transform of x with the time scale signal can be written as 1 by a mod, because when a is less than 0, then it is comes out to be negative. When a is greater than 0, that comes out to be positive. Then we can take the absolute value of a, that is multiplied by 1 by absolute value of a, that is multiplied by x, the function of j omega a. Now if this a value is greater than 1, then xat is a compressed version of xt. That is a compressed version of xt, right, by the factor of a, and the corresponding Fourier transform is the expanded version of xj omega. So that is that has to be understand that if this x a t is a compressed version of xt, तो इसका फोरियर ट्रांसफॉर्म होगा x j ओमेगा बाय a, वो इसका एक्सपेंडेड वर्जन होगा. इट इज एक्सपेंडेड वर्जन ऑफ x j omega by the factor a. In the other hand, this is the first understanding. Second understanding is, on the other hand, if a is less than 1, then xat is expanded version of xt by the factor a, and the Fourier transform what we are having xj omega by a is the compressed version of xj omega by the same factor a. So the signal compressed in time results in the expanded frequency spectrum and vice versa. So this is the all concept we are discussing here. So please like the video and subscribe the channel.